Introduction to wireless LANs. Now, in the past few years, wireless LANs have become a very viable alternative to wired LANs in many situations. But first off, what is a wireless LAN? Well, that's exactly what we're going to learn about in this video. So we're going to start things off by learning about a little bit of the history of wireless LANs and the benefits of wireless LANs and the different applications of wireless LANs, or meaning where wireless LANs are best implemented. So are you ready to get started? Excellent, that's what I love to hear. So first off, what is a wireless LAN? Well, in order to answer that question, we're going to bring up another whiteboard. Now, in a nutshell, a wireless LAN is a computer network which uses radio frequencies, which is also referred to as RF, uses radio frequencies to transmit data to other computers and devices on a wireless LAN. And a LAN stands for Local Area Network. Now, historically, computer networks have usually been created by establishing a physical connection between the computers by using cables such as Ethernet cables. Now, as I mentioned earlier, it's only been in the past few years where wireless LANs have become a really viable method for creating a computer network. However, the technology for wireless LANs has really been around for a long time. For example, back in World War II, the U.S. military was able to transmit battle plans and perform ship-to-shore communication with naval vessels using radio signals, by using encrypted radio signals, I should say. And the actual very first wireless LAN, though, was created in 1971 by the University of Hawaii. The University of Hawaii was able to connect 7 different computers which were spread out over 4 different Hawaiian islands to a central computer on the island of Oahu, all via wireless connection. So the very first wireless LAN was actually created all the way back in 1971, but that was more of a grand experiment. It really wasn't ready for prime time, so to speak. The actual birth of wireless LANs didn't happen until 1997, when the Institute of Electrical and Electronic Engineers ratified a standard for wireless LANs that we use today, and that standard is known as IEEE 802.11. And there's actually several IEEE 802.11, or also known as 802.11 standards, which we'll learn about in the Wireless LAN Organizations and Standards video in this exam pack. Now, on this whiteboard, what we're looking at is a very common method for deploying wireless LANs. Most wireless LANs are deployed in what's referred to as a access layer role. And that essentially means that the wireless LAN is serving as an entry point to access a wired network. So in this example, we have 3 laptops, all of which have a wireless network adapter that are connected to a wireless access point, which in turn is physically connected or has a physical wired or cable connection to the wired network. So this allows the laptops on this wireless network, which we have right here, access to each other, so these computers can connect with each other. But this wireless access point is also acting as an access point to the wired network. And another way to think of this is that it's acting as a bridge between the wireless network and the wired network, and as a result, these laptops will be able to gain access to computers and resources not only over here, but also on the wired network as well. Now, at this point, you might be asking yourself, though, well, how in the world do these laptop computers with this wireless network adapter establish a wireless network connection to begin with anyhow? Well, remember, going back to my earlier point, that wireless local area networks, or wireless LANs, are created by using radio signals. And they transmit data by using radio signals. But they transmit data using radio signals at a very specific frequency, though. And this is very similar to using a radio to listen to music on an AM or FM radio frequency. So, for example, the radio station will broadcast its radio signals over a radio tower, and in order to receive those broadcasts, you'll have to tune in your radio to this specific frequency. So, for example, if a radio station broadcasts over a frequency of FM 95.5, you'll have to tune your radio into that same frequency to listen to the music that's being broadcasted at that frequency. Well, in a wireless LAN, the wireless access point, which is also known simply as an AP, is acting as the radio tower. It's a beacon that's transmitting these radio signals, but it transmits the radio signals at a specific frequency. So the computers with a wireless network adapter will have to tune into the same frequency that the access point broadcasts out in order to connect to and be part of a wireless local area network. We'll learn about the actual wireless connection process and these frequencies in other videos within this exam pack. Now, an area of the network that you typically won't find a wireless local area network is the core part of the network that contains your critical components of the computer network, such as your email servers and your database servers and other critical application servers and file and print servers. The wireless network just doesn't have the speed and the stability and security that a wired network has at this point. And wireless networks solve a lot of problems associated with wired networks. Wired networks are very expensive. It costs a lot of money to purchase the cabling, to install the cabling, and to maintain the cabling. Plus you have all this clutter of cabling. And because of all this cabling, a wired network is very rigid. In order to get connected to the wired network, you have to physically take a cable from your computer, plug it into a jack in the wall to get connected, but you don't have the mobility in a wired network that you do have in a wireless network. Also, a wired network is not very flexible. If you need to increase the size of your wired network because you're hiring more employees, you're experiencing growth, and you rent out a couple more floors within the building that you're working out of, or you purchase another building, it can be very difficult and very costly to add to your wired network. In contrast, a wireless network is very mobile. As long as the computers, the wireless devices, are within the coverage area of wireless access points, you are connected to the wireless network and in turn to the wired network. You've got reduced costs by using a wireless network. You don't have the costs associated with the wires and installing and purchasing that cabling. It's very flexible. Wireless networks can be installed very quickly and very easily and can be used to extend wired networks quite quickly. So again, a wireless network is not a good choice for the core part of the network that requires stability, security, and speed. However, a wireless network is excellent for certain situations, such as extending the network. Let's bring up another whiteboard and talk about this a little more here. And so in certain situations, you might need to physically extend the network to other floors within a building, or in this case, we've got this large warehouse where we've got the servers and the core part of the network all the way over here. And if this is a huge warehouse, we could have two problems here. Number one, it could just be cost prohibitive for installing all the cabling associated with physically extending the network from, let's say, this side of the warehouse all the way over to this side of the warehouse. So that's problem number one. And for problem number two, due to the maximum length of Category 5 Ethernet cable restrictions, it can hamper as to actually how far you can physically extend your wired network, in which case you could use fiber optic cable, but that becomes a very expensive solution, and you probably have to upgrade existing switches to accommodate fiber cable as well. So in this example here, we have set up a wireless access point that is connected to the wired part of the network, which in turn allows you to extend your network to allow additional clients to partake not only on the wireless LAN but also on the wired network as well. So using a wireless LAN is an excellent method for solving these two problems, for extending your network. Now, in addition to extending a wired network within the same physical location, we also might need to extend the wired network to adjacent locations. So for example, our wired network might have to be extended to a building next to our building. Let's bring up another whiteboard and learn about that. So on this whiteboard we have two buildings that are relatively close together, and there's a computer network in both buildings. However, we'd like to combine those networks together to create a single network to allow users in both buildings to essentially be on the same computer network. And wired connectivity can be established between these two buildings by either running cables underground from one building to another, or by renting very expensive leased lines from the local telephone company. So both these solutions are very expensive and very time-consuming. So in this example, instead of using a wired method for establishing network connectivity between the two buildings, we're using a wireless method. So each building has its own wireless antenna, which is used to help establish a wireless connection between the two buildings. And in this example, where we only have two buildings that are connected together via this wireless connection, this is referred to as a point-to-point wireless connection. So it involves only two buildings. In contrast, if we have a wireless connection between three or more buildings, this is referred to as a point-to-multipoint connection. Now, when we have three or more buildings connected together in a point-to-multipoint wireless connection, they're usually connected in what's referred to as a hub-and-spoke topology. And in that type of topology, we have one central part of the network. So, for example, if we add in a third building right here, just draw it right in the middle here, and this third building is going to be the core part of our network. It's going to be the high-speed backbone with our key servers, and we're going to put an antenna on here. So this core building is going to be the hub of the network. And the spokes of the network will be these adjacent buildings. So this will be a spoke, and over here this is a spoke as well. So in this type of topology, instead of having the buildings connected directly to each other, the buildings or these spokes will connect to the hub. So in this situation, they're going to be connected to the central or the core part of the network. Now, wireless connectivity can be used not only for extending your network and for combining your network together in building-to-building connectivity, but it can also be used to provide access to the Internet. Let's bring up another whiteboard and learn a little more about this. Now, a very common method for connecting to the Internet is by using a dial-up connection or a cable modem connection or some type of DSL connection. However, those type of connections may not be available in rural areas or hard-to-reach areas. So, for example, in a rural area, it could be cost prohibitive for the cable or telephone company to provide a broadband connection from the cable or telephone company to the actual customer. The actual wired connection, the communication infrastructure that extends from a cable or telephone company to a customer's home is referred to as the last mile delivery. And it can be very, very expensive to try to provide a connection from the cable or telephone company all the way to a house that might be miles and miles and miles away from the closest location for a telephone company or a cable company. So, for example, in order for a telephone company to provide DSL service to a customer, the customer can't be more than 18,000 feet, which is just a few miles from the telephone company's central office. So in situations like this, a customer has two choices. They can establish a connection to the Internet either by a satellite connection, or if there's a wireless Internet service provider within reach of their house, they can also have the wireless Internet service provider, which is the acronym WISP or WISP. The wireless Internet service provider can provide the last mile of delivery service to the customer's home through a wireless connection, as we have here on this whiteboard. So a wireless Internet service provider can fill in the gap between providing DSL and cable modem connection for broadband connections for customers. So if a customer is not able to receive those services because it's just cost prohibitive for laying down cable between the telephone company or the cable company all the way to a customer's house, now in this example we're using a wireless connection from a wireless Internet service provider to establish a connection from the customer's house to the wireless Internet service provider's tower and in turn to the Internet. So in this example, the wireless Internet service provider has a radio tower that sends out wireless signals to customers that have a wireless antenna on top of their house, and there's a cable that goes from that wireless antenna, goes into the house and connects to a special type of modem, which in turn is connected to the customer's computer, which in turn allows that customer to get a wireless connection to the Internet. Now, the big gotcha about using a wireless Internet service provider for Internet connectivity is that you need line of sight between the antenna on the house and the wireless Internet service provider's radio tower. So if there are obstructions to the line of sight between the antenna and the radio tower, such as trees or rooftops, or getting in the way between that signal, that can prevent you from establishing this wireless connectivity, or it can provide intermittent service. It's just kind of flaky service. And I actually had a wireless connection to the Internet through Earthlink. And in my situation, the fellow that came out to install the wireless antenna had to place a 6-foot pole on the top of my house in order to provide an unobstructed, clear line of sight between the antenna on the top of my house and the radio tower, which was on a mountain several miles away from my house. But there are several houses next to me and some trees a little further down that were blocking my line of sight between the antenna in my house and the wireless internet service provider. So the solution to that was to put this huge, ugly pole on the top of my roof so we can get clear line of sight between my house and the wireless internet service provider's tower. Also, a wireless internet service provider may also use the same method for creating hotspots, which is a location where you can establish a wireless connection to the internet. And this is typically done at public locations such as airports, hotels, cafes, things like that. Now, an area where wireless networks really pay for themselves and allow people to be more efficient is the mobility that they have to offer. Let's bring up another whiteboard and learn a little more about this. For companies that have warehouses that need to keep track of their inventory in their warehouse, wireless networks are really a time-saving device. The old method for tracking inventory in a warehouse was to manually key in the inventory data at a wired terminal. Now users can save a tremendous amount of time by using handheld wireless devices with a barcode reader where they can scan in the inventory as it's received and scan the inventory out as it's being shipped. So, for example, shipping companies such as FedEx or UPS and companies like that will use a handheld wireless device that's equipped with a scanner, which in turn gets them connected to the wireless network, which in turn gets them connected to the wired network, and allows them to have just immediate update of their inventory and receiving packages and shipping packages. So, for example, when they're receiving packages at the loading bay, the packages will typically have a barcode, and they just wave that handheld device over the barcode, and they have instant inventory update as far as incoming and outgoing update for receiving and sending packages. So it's a tremendous time-saving device. And you'll find wireless devices such as this are used in a tremendous amount of different applications, such as point of sales, even in retail stores, or all the way to doctors using them in hospitals to get up-to-date information or even issuing prescriptions. Now, so far we've been talking about the use of a wireless LAN in the context of businesses and wireless internet service providers, but wireless LANs also benefit home users and small business users as well. Let's bring up another whiteboard and learn a little more about this. Now, it's becoming more and more common these days for households to have a single high-speed broadband connection to the internet through a cable modem connection or a DSL connection. But more and more households also have multiple computers. They have 2 or more computers. So people want to use this single connection to the internet and share that connection among all the computers that they have in their house. Well, one way to go about doing this is to use some type of router that connects to the cable or DSL modem through a wired connection. And this in turn would require that all the computers within the household have a wired connection from the computer to the wired router that is connected to the cable or DSL modem. And this can be a very expensive, very time-consuming process trying to wire your house with Ethernet cable after it's been built. So in these days, the very quick, very less expensive option or solution to this problem is instead of using a wired router where you've got wire either going through the walls or stringing down the hallway in your house or apartment, use a wireless access point that is also acting as a router. So in this situation, we equip the computers with a wireless network adapter, and in turn, they will connect to the wireless access point that is connected to either the cable or DSL modem, which in turn allows them a shared connection to the internet. Now, wireless access points have become relatively inexpensive. You can purchase a wireless access point easily for under $100, which makes it a very viable solution for allowing a household to share a single internet connection through a wireless access point. I've personally had a wireless LAN in my house for the past 3 years, and it's been very convenient having the mobility of being able to move from room to room to room. I often take my laptop downstairs to the kitchen and check my email down there, and at the same time still can keep my eye on the kids and see what they're doing, or I can take my laptop out to the backyard and I still have a good, strong wireless connection to my wireless access point that is in my office upstairs, so I can still watch the kids, keep my eye on the email, and still be connected. It's very cool stuff. Now, something to keep in the back of your mind when you're setting up a wireless LAN, either within a home environment or within a company network, is that the radio signals in a wireless LAN will pass through walls and floors. However, How many walls and floors the radio signal will go through really depends on the type and the thickness of the material that's used for the walls and floors. So for example, the radio signal can pass pretty easily through sheetrock walls. However, if you have walls or floors that have steel reinforcement, or if the floors are reinforced concrete floors, that radio signal is going to weaken quite a bit. So, for example, you don't want to place a wireless access point right butt up against a steel filing cabinet, as that will weaken the radio signal that's being sent or broadcast from the wireless access point. Now, the technical term for the signal being weakened is referred to as attenuated. So when you hear that word attenuated, it means that the signal is being weakened. Now, another excellent use for wireless LAN is with mobile offices or mobile classrooms. Let's bring up another whiteboard and take a closer look at this. Now, universities and grade schools also face the same type of situations of extending their computer network as do corporations and small businesses. They certainly benefit by the mobility and the reduced costs and the flexibility and the reduced installation time that wireless LANs have to offer. For example, if a school student population grows so quickly that it outstrips the school's capacity for providing seating for the students, you'll find that schools will use portable classrooms that basically look like big old trailers just kind of parked out in a parking lot somewhere. And these portable classrooms typically need to be connected to the main part of the school that has the core part of the network, so teachers can check email and perform other related tasks. So an example such as this, the fastest and most cost-effective method to connect the portable classroom to a school network is through the use of wireless technologies. Now, another area where wireless LANs are really beneficial is for movable networks. Now, not only do wireless LANs provide mobility for people that use mobile wireless devices such as a personal digital assistant or PDA, but they're also very useful for a temporary network. For example, in special events, maybe a football game needs a temporary network, and a wireless LAN is perfectly suited for that, or for trade shows or festivals, or maybe a temporary network is required for a construction company or something out in a field type situation. These are excellent situations for being able to quickly and cost effectively setting up a network by using wireless LANs. And with that, that brings us to the end. Let's bring up our introductory whiteboard and do a recap of what we learned here. So we start off by learning that a wireless LAN uses radio signals to transmit data, and the use of radio signals for transmitting data stretches all the way back to World War II with the U.S. military, but the very first wireless LAN was set up in 1971 by the University of Hawaii. And we learned that wireless LANs are best used in an access layer role in contrast to a core layer role part of the network, because the core part of the network requires the speed, stability, and security that wireless LANs just don't provide at this point. However, wireless LANs provide mobility, flexibility, reduced costs, and reduced installation times compared to wired networks. And wireless networks are well suited for network extension, building-to-building connectivity, used by wireless internet service providers or by a mobile workforce. They're great for SOHO environments, small office, home office, and also for schools. And one thing is absolutely certain, and that is wireless technologies are here to stay. They're getting faster, they're getting more secure, and they're getting cheaper day by day, and more uses for wireless technologies appear day by day. And with that, that brings us to the end. I hope that this video has been informative for you, and I'd like to thank you for viewing.